Good afternoon, all. You're welcome to our online classes. If you can remember, in the last class, we treated components on solar installation, where we talked about inverter batteries, and we promised to consider load analysis. Because if you can remember, I told you for us to get the required component, we have to know the what we call load analysis. Okay, so basically these are the home appliances. These are the minimum home appliances. We have ceiling fan, we have bulbs, we have phone chargers, we have television, we have heater, we have submersible pump, and then we have pressing iron. So now, based on this information given by the client, then we have to perform a table like this. What is the power rating to the ceiling fan? Normally, ceiling fan, we have long blade and short blade. If it is a long blade ceiling fan, normally it has 60 watt. And that is why we wrote 60 here. Okay, for the bulbs, we have different rating. LED, we have CFL, we have incandescent, we have halogen, and what have you. In this case, we consider LED bulb in form of 5 watt. We have 5 watt, 6 watt, 10 watt, 12 watt, and what have you. So now we select 5 watt. Okay, the phone charger, we select 5 watt also. Television, we go for 100 watt. Heater, 1000, of course, is a resistive load. It has filament, so it actually consumes, it's a resistive load, it consumes higher power, and that is why it is 1000 watt. Heater, pressing iron, they do consume high power. Hot plates, all right? Then submersible pump is 0.5 horsepower. You know, we have to convert horsepower into real power. So, and that is why, you know, each 1 horsepower is equivalent to 746 watt of real power. So since our pump is rated 0.5 horsepower, which means half of 1 horsepower is 373 watt. And pressing iron here is 600 watt. Of course, you can have a smaller rating pressing iron, you can have a bigger rating pressing iron. So in this case, they consider 600 watt. So now, this is the power rating to the appliances. We have to look at the what? The quantity of these appliances. For the ceiling fan, we require 3 numbers, bulb 6 numbers, phone charger 3, television 2, heater 1, pump 1, and pressing iron 1. Okay, and then we move to the power factor. This power factor, okay, this is 3, and this is 6, 1, 1, 1, okay? Okay, so now each appliance has what we call power factor. For appliance to work better, which means you need to have a power factor close to 1, which is what called unity. Now, the closer to unity, the better the performance of the appliances. That is why, if you are not carried away, we have inverter AC, we have inverter fridge, and so on and so forth. Anyhow, you hear this inverter appliance, it means they have a better power factor. Okay? If the power factor is very poor, which means the appliances, be it a refrigerator, air condition, and whatever, it will consume higher power. So now, for the ceiling fan, it has power factor of 0.6. For the phone charger, it has some phone chargers are having fast charging, some are having, you know, intermediate. So in this case, if our power factor is 1, then so be it. But if the power factor is less than 1, you have to consider it. And then bulb 1, phone charger 0.8, television 0.8, heater 0.9, pump 0.9, and iron 0.9. So for us to get the inverter rating, we say the power rating times the quantity divided by what? Power factor. That will give us the capacity needed to what? To power the ceiling fan. So 60 times 3 divided by 0.6 will get 300 watts. Okay? For the bulb, we have 5 watt times 6 numbers divided by 1 is what? Because 5 times 3 is 30, divided by 1 is what? 30. Okay. Then for the television here, phone charger, sorry, 5 times 3, 15 divided by 0.8 will have 18.75 VA. Okay, television 100 times 2 is 200 divided by 0.8 we will get 312.5 VA. Okay, all right. So now, after doing all this, we move to pressing iron. For the pressing iron, 600 divided times 1 divided by 0.8 will get 667 VA. So cumulatively, you sum all this rating obtained after doing the calculation, then you arrive at a figure here. So for you to get the actual inverter capacity, what are you supposed to do? You sum all this. We have 2,853.75 VA. Okay? Or we say 2.85375 kVA. Okay. Do we have this inverter available in the market? No. So which means, and this is ideal, if we own all the appliances at a time, it is expected to consume this type of power. As such, we have to what? Take it to the nearest available inverter, which is what? Either 3000 VA to 3500 VA. Why did I mention between 3000 to 3500 VA? If we take 3000 VA or 3 kVA, of course it can serve this purpose. But in case of what? Additional expansion in the house, it's better you go for 3.5 kVA. At least we have a bigger space. In case when you intend to add extra load, the inverter is capable of taking all the appliances. So now as such, we are going to select 3.5 kVA. And of course, 3.5 kVA inverter is taking 24 volt as what? System voltage. It means it requires 2 numbers of batteries. 2 number of batteries. This is a minimum number. Okay? So since we have gotten the inverter capacity and the system voltage, we note it. Our inverter is 3.5 kVA of what? 24 volt DC. Then we already obtained our inverter rating here. What else?